Hello everyone, my name is Vara, and today we will be learning about the basics of Python. Python is a powerful and easy to learn programming language used in web development, data science, automation, and more. In this session, we will explore key Python concepts that are essential for beginners. Let's get started and dive into the basics of Python programming. Welcome to the introduction to Python. Python is a widely used programming language known for its simplicity and versatility. It is one of the most popular programming languages in the world. Python is designed to be easy to read and write. It uses simple keywords and a clean structure that makes coding more efficient. This is why Python is recommended for beginners as well as experienced developers. Python is an interpreted language, which means it executes code line by line. This makes debugging and testing faster compared to compiled languages. Python is also dynamically typed. This means that you do not need to specify the type of variable while writing the code. Python is used in various fields including web development, artificial intelligence, data science, automation, and game development. It is widely adopted by big companies such as Google, Facebook, and Netflix. One of the main reasons for Python's popularity is its vast collection of libraries and frameworks. These tools help developers to build applications more efficiently without writing everything from scratch. Python is also known for its cross-platform compatibility. It can run on Windows, Mac, and Linux without any modifications. This makes it an ideal choice for developers working on multiple platforms. Learning Python opens the door to many career opportunities. Whether you want to become a software developer, data analyst, or machine learning engineer, Python provides the foundation needed for success. In this tutorial, we will explore the basics of Python, starting with its syntax and key features. Let us begin the journey of learning Python. Now, let us explore the key features of Python that make it one of the most powerful and widely used programming languages today. First, Python has a simple and readable syntax. Unlike other programming languages that use complex symbols and structures, Python follows a clean and easy to understand format. This makes it beginner-friendly and reduces the time needed to learn programming concepts. Second, Python supports object-oriented programming. This means you can create reusable code using classes and objects. Object-oriented programming helps in organizing code efficiently and makes it easier to manage large projects. Third, Python is a cross-platform language. It runs on different operating systems including Windows, Mac, and Linux without requiring major changes in the code. This makes it convenient for developers who work on multiple devices. Another important feature is Python's extensive standard library. Python comes with a wide range of built-in modules and functions that allow developers to perform complex tasks such as working with files, handling data, and connecting to the internet. Additionally, thousands of third-party libraries are available for specialized tasks such as artificial intelligence, web development, and data science. Python also provides automatic memory management. It handles memory allocation and deallocation automatically, reducing the risk of memory leaks and making it easier to write efficient programs. Python supports dynamic typing. This means you do not need to declare the type of a variable before using it. The interpreter automatically detects the type based on the assigned value. This makes Python flexible and speeds up the coding process. Another powerful feature of Python is its ability to support multiple programming paradigms. It allows both procedural and functional programming styles, giving developers the freedom to choose the best approach for their projects. Python also has strong community support. Millions of developers around the world contribute to the Python ecosystem, creating new tools, libraries, and resources. This ensures continuous improvement and a vast amount of learning materials for beginners and professionals. Finally, Python is widely used in cutting-edge technologies such as artificial intelligence, machine learning, and automation. Companies like Google, Tesla, and NASA rely on Python for developing advanced applications. With all these features, Python continues to be a preferred choice for developers across different industries. Now that we have explored its key features, let us move forward and learn about the Python development environment. To start coding in Python, you need to set up the right development environment. Setting up Python is simple and does not require complex configurations. The first thing you need is the Python interpreter. This is the program that runs Python code. You can download the latest version of Python from the official website python.org. The installation process is straightforward. Make sure to check the box that says Add Python to Path during installation. This will allow you to run Python from the command line easily. Once Python is installed, you need an integrated development environment, also known as an IDE. An IDE is a software application that provides tools for writing, testing, and debugging code efficiently. There are several popular IDEs for Python. The first one is PyCharm, which is widely used by professional developers. It provides powerful features such as code completion, debugging, and project management. The second option is VS Code, also known as Visual Studio Code. This is a lightweight and fast editor that supports Python extensions. It is a great choice for beginners and professionals. Another popular option is Jupyter Notebook. This is widely used in data science and machine learning. It allows you to write and execute Python code in an interactive environment. Once you have installed Python and chosen an IDE, you are ready to start coding. Now, let us move on to basic Python syntax. Basic Python syntax. Python uses a simple and clean syntax, making it easy to read and write. Unlike other programming languages, Python does not use curly brackets to define code blocks. Instead, it uses indentation. This means that the number of spaces or tabs at the beginning of a line determines how the code is grouped together. Let us look at a simple Hello World program in Python. This is the first program that beginners usually write. The code looks like this. Print, hello, world. This program contains a single line of code. The print function is used to display text on the screen. The text inside the parentheses is written in quotation marks. This tells Python that it is a string, which is a type of data used to store words and sentences. When you run this program, Python will display the message hello, world on the screen. This simple example demonstrates how Python executes code in a straightforward way. Python programs follow a few important rules. First, Python is case sensitive. This means that print with an uppercase P is different from print in lowercase. Always use lowercase for Python commands. Second, Python ignores spaces and empty lines unless they are used for indentation. This makes the code more readable and organized. Finally, Python does not require semicolons at the end of statements. This is different from languages like Java or C++, where semicolons are mandatory. Now that we have covered the basics of Python syntax, let us move forward and explore Python fundamentals. Overview of Python fundamentals. Python fundamentals are the essential building blocks that help in writing effective Python programs. Mastering these concepts allows developers to create efficient and structured code. Variables and data types these define how data is stored and manipulated in Python. Python supports multiple data types, including integers, floating point numbers, strings, lists, dictionaries, and booleans. Operators help in performing calculations and making logical decisions. Python provides arithmetic, logical, and comparison operators for different operations. Control statements, these include if-else statements and loops that allow decision-making and repetitive execution in programs. They help in controlling the flow of execution based on conditions. Functions and modules. Functions allow code reuse by breaking a program into smaller, manageable sections. Modules provide pre-written code that can be imported to extend Python's functionality. Classes and objects. Python follows an object-oriented programming approach, enabling developers to structure their code efficiently by creating classes and objects. These 5 core concepts form the foundation of Python programming. Now, let us explore each one in detail in the upcoming sections. Python variables and data types. Let us explore variables and data types in Python. In Python, a variable is like a labeled storage box that holds different types of data. The best part? Python automatically figures out the type of data you are storing so you do not need to specify it. For example, in the code shown on the slide, the variable name is set to Alice, which is a string, meaning it stores text. Temperature is assigned 36.5, a float, representing decimal numbers. Age is given the value 25, which is an integer, used for whole numbers. Finally, is_student is set to true, a boolean that represents a true or false value. Python makes working with variables super simple. You just assign a value, and Python takes care of the rest. Want to try it yourself? Open a Python editor and experiment with different values. Happy coding! Python operators. In this section, we will explore Python operators, which are used for performing calculations, comparing values, and making logical decisions in a program. Arithmetic operators. Arithmetic operators are used to perform basic mathematical operations. For example, if x is 10 and y is 5, then x plus y gives 15. X multiplied by y gives 50. These operations allow us to work with numbers in Python easily. Comparison operators. Comparison operators are used to compare values. They return either true or false, depending on the condition. For example, x greater than y returns true. X equal to y returns false. These operators are useful when checking conditions in a program. Logical operators. Logical operators help combine multiple conditions to make decisions. For example, if x is greater than y and x is not equal to y, then since both conditions are true, the result is true. Logical operators are commonly used in if statements and other decision-making processes in Python. Refer to the slide for code examples. To see how these operators work in Python, look at the slide for the example code. It demonstrates arithmetic, comparison, and logical operators in action. Summary of Python operators. Arithmetic operators perform mathematical calculations. Comparison operators compare values and return true or false. Logical operators combine multiple conditions for decision making. Python makes using operators simple and efficient. Try using them in a Python editor and see how they work. Python control statements. Control statements determine the flow of execution in a program. They include decision-making structures and loops. If-else statements. If-else statements allow a program to make decisions based on conditions. For example, if a value is greater than 5, one block of code runs. Otherwise, a different block runs. For loops. If a loop repeats a block of code a specific number of times. For example, if a loop runs 3 times, it executes the same block of code for each iteration. While loops. A while loop repeats a block of code as long as a certain condition remains true. For example, if a counter starts at 0 and increases by 1 each time, the loop will continue running until the counter reaches a specific limit. Refer to the slide for code examples. Look at the slide to see example code for if-else statements, for loops, and while loops. These examples demonstrate how control statements work in Python. Summary of Python control statements. If-else statements execute code based on conditions. For loops, repeat a block of code a fixed number of times. While loops, repeat a block of code while a condition is true. Control statements help manage the flow of a program, making Python code more efficient and structured. Try using them in a Python editor to see how they work in action. Python functions and modules. Functions and modules help organize code and allow reusability in Python. They make programs more structured and efficient. Functions. A function is a block of reusable code that performs a specific task. For example, if a function is created to display a greeting, it can be used multiple times without rewriting the same code. Built-in and custom functions. Python includes built-in functions like print and len that perform common tasks. Custom functions are user-defined and created for specific needs, allowing more flexibility in programming. Modules. A module is an external Python file that contains reusable functions. For example, the math module includes mathematical functions that can be accessed using the import statement. Importing modules. To use functions from a module, the import statement is used. This allows access to additional functionality without writing extra code. Refer to the slide for code examples. Look at the slide for example code that demonstrates how to define a function, call a function, and import a module in Python. Summary of functions and modules. Functions are blocks of reusable code that perform specific tasks. Built-in functions are predefined in Python, such as print and len. Custom functions are user-defined for specific purposes. Modules are external files containing reusable functions. Importing modules allows access to additional functionality using the import statement. Functions and modules help make Python programs more efficient and organized. Try creating and importing functions in a Python editor to see how they work in action. Python classes and objects. Classes and objects are the foundation of object-oriented programming in Python. They allow data and behavior to be grouped together in a structured way. Classes. A class is a blueprint for creating objects. It defines properties and behaviors that the objects will have. Objects. An object is an instance of a class. Each object has its own attributes and can perform specific actions using methods defined in the class. Constructor method. The init method, also called the constructor, initializes the properties of an object when it is created. This ensures that each object starts with specific values. Methods. Methods are functions defined within a class that describe the behavior of the objects. These methods allow objects to perform actions. Encapsulation. Encapsulation restricts access to certain data within a class, making it more secure and organized. It ensures that only specific parts of the program can modify the data. Refer to the slide for code examples. Look at the slide for example code demonstrating how to define a class, create an object, and call a method in Python. Summary of classes and objects. A class is a blueprint for creating objects. An object is an instance of a class with specific attributes and methods. The constructor method initializes object properties when an object is created. Methods define the behavior of objects. Encapsulation helps restrict access to certain data within a class. Understanding classes and objects is essential for writing organized and reusable code. Try defining a class and creating objects in a Python editor to see how object-oriented programming works in action. Please support this channel by subscribing, liking, and sharing this video. Your support encourages us to create more valuable content and tutorials. Don't forget to turn on notifications so you never miss an update. Thank you.